The first type of bonding we're going to look at is metal bonding. It's called metallic bonding. And let's say, for example, I were to take something like sodium. We all know sodium would like to get rid of its electrons, so it gets rid of an electron. And the next sodium also gets rid of an electron. And none of those sodiums are keen to actually take anybody else's electron, so the next one also gets rid of an electron. And what happens is you have a whole bunch of spare electrons in a metal. That makes some sense. Why? Because metals are able to conduct electricity. Why can they conduct electricity? Because there are all these extra electrons lying around. So let's just take a look at what happens to where electrons go and what happens in a metal. So over there is a metal, and there are a whole lot of atoms in that metal. And the valence electron the atom doesn't want, so it gets rid of them. And these are called positive kernels. So each metal there is positively charged with its core electrons, because it has sent its valence electrons into what we call the sea of delocalized electrons. Now let's look at that. So we have what are called positive kernels, which is the core ions of metals. So examples: Na plus, Mg 2 plus, Fe 2 plus, Cu 2 plus. All of those are the core ions. They are called the kernels. And then you have a sea of delocalized. What does delocalized mean? Delocalized means that they have no location. They have no home. Sea of delocalized electrons. I often say that the positive kernels have thrown their electrons, their babies, into the traffic to go and play. So all they go, they don't want them, poof, into the traffic to go and play. Now all those spare electrons are lying around in a metal, which allows for the conducting of electricity. And now if I put a potential difference on either side of that metal, you will see that the electrons will go from the negative side towards the positive. So they are being conducted across there. None of these positive kernels care about which electrons are nearby them. But what would happen if one positive was right next to another positive and there was not a little electron around about? Then they would repel each other. So these electrons act as the glue that hold the lattice together. So they stick the lattice together, and the force of attraction between negative electrons and positive kernels is called an electrostatic force, or sometimes we also call it a Coulombic force. So that is a force of attraction between the positive and the negative, and it is the negative electrons that hold the positive kernels, these ions, in the lattice. Now we need to know this word lattice. Lattice simply means a solid structure. So these positive kernels are arranged in a very organized fashion, and that is a crystal lattice or a metallic lattice, a metallic solid with organized atomic structure. So let's look at the rules of, or the theory of, metallic bonding. Metals have got a high density. Why? Because the metal atoms pack closely together and then their orbitals overlap. These metal atoms then become metal ions because they get rid of their electrons. The electrons in the overlapping orbitals become delocalized. They do not have a specific location. This particular positive kernel does not care which electron is its neighbor. These ones can all flow through the metal with nobody caring. They are delocalized. But they do have to be there in order to stick the lattice together. The delocalized electrons are free to move in other atoms' vacant orbitals in the space of the molecular orbital. This means that they are able to conduct electricity, and the positive kernels are held together by the sea of delocalized electrons using electrostatic forces.